Greetings and welcome. So we're talking about multiplying matrices. This is off of a worksheet from an Algebra 2 book, Prac 4.3. And looking at number 5 here, I'm multiplying these two matrices. The first thing that you should consider before you're even trying to figure out what you're multiplying here or whatever is the size of these matrices. So let's see. The first one here on the left has 2 rows. Right, so 2 and 1, 2 columns, so it's a 2 by 2 matrix. The one on the right here has 2 rows and 1, 2, 3 columns. So, question, can I multiply these matrices? Yes, these inner dimensions must match, okay? So the columns of the first matrix must be the same as the rows of the second matrix. And then our answer matrix is going to be what size? 2 by 3, right? It's the outer dimensions that make up our answer matrix. So this is going to equal, I'm expecting a 2 by 3, so I'm thinking of 1, 2, 3, sort of, right, and 2 rows is what I'm kind of expecting here, right? So let's start filling these out. In order to do this, I'm going to multiply row by column, kind of like my little roll call sort of way to memorize rows by columns, right? Pretty much matrices, we do that all the time. Row call, row call. So for my first row, first column entry in my answer matrix, I'm going to multiply the first row by the first column. And I'll have 2 times 3 plus 4 times 6, right? And that will be that. For the next one, I will multiply, let's see, this is the first row, second column. It doesn't matter to me if you do this one or this one next, but they will have different work. So I'm doing first row, second column, so I'm going to multiply the first row by the second column. So that's 2 times negative dos plus 4 times 0, right? Next, I'm going to multiply, let's see, I'm looking for this element. So I'm going to multiply the, let's see, that's the first row, third column. So I want to multiply the first row by the third column, right? That's kind of, yeah, that's good enough. So that'll be 2 times 7 plus 4 times negative 5. And I think I know, all right, I can close my brackets here. Bam. So this is a matrix. It's got to have these little top and bottom parts, right? It's kind of like, almost like an I-beam, but not having the other side, right? So it's just like, I don't know, is there such a thing as a C-beam for steel? I don't know, probably wouldn't make much sense. Whatever. And let's see, let's keep going. So now I'm looking for this element, which is the second row, first column. So I'll multiply second row by the first column, right? And I'll have 3 times 3 plus negative 1 times 6. I'll throw parentheses around it. Why not? Let's see, then I'll have second row, second column. That's actually kind of dark. Let's see. That's a slightly different blue. Ooh, I've got a nice purple going on here. So I'll multiply the second row by the second column, and I'll have 3 times negative 2 plus negative 1 times 0, right? And let's see, I need like one more color. I'm desperate here. What's it going to be? Ooh, I think this is an interesting bluish, greenish, kind of similar to that. I haven't done pink yet? Okay, yeah, that's slightly different. So, I'm looking for second row, third column, so I'll multiply the second row by the third column. 3 times 7 plus negative 1 times negative 5. So let's figure out what this is equivalent to. I like the colors, man, fruity pebbles. 6 plus 24 is 30. Negative 4 plus 0 is negative 4. 14 minus 20 is negative 6. All right, hopefully I'm right so far. 9 minus 6 is 3. Negative 6 plus 0 is negative 6. And 21 plus 5 is 26, right? So they can just show up.
Okay.
But I sent them an email out online, so they can accept it on their Google Calendar if they want.
Oh, okay.
So they get that
Because I
as
was going
well.
to put it in the bulletin. I just wanted to...
Sure, I think I did put it in the
You did, but I
announcements.
didn't. I wasn't sure if you wanted pre-registration.
Nah.
Okay, thank you.
Yep, very good.
Carry on.
Yep. So this is how you do this. I mean, it's a little bit crazy for the math, and like I said, I won't. Well, I wouldn't require you to write like an in-between step for this of like, oh, 2 times 3 is 6 plus 24. But it might make sense, at least on a quiz or short answer. You don't want to just like do it and then like get all of your points wrong because you happen to be wrong, and then I can't follow your work, right? So it might be good to write something like this down, but you don't need to use all the colors, so don't worry too much about that. Let's look at problem 7 here. As always, first thing I want to do is compare the sizes. All right, the size of this first matrix is 2 by 3. The second matrix is 2 by 3. I could add these matrices because they're the same size. I could subtract them because they're the same size. But I cannot multiply them because the middle numbers don't match. Right? Wah, wah, wah. So this is, I guess the answer is no. Just like no. Never. I won't. You can't make me multiply those matrices. No, or the book wrote, not possible to evaluate. Right? So, imposible. Right? And then also, I just want to point out, if I did try my row column thing, notice I'd try to multiply 3 by this column, and I'd be like, uh-oh, I need like another element right here to multiply this 7 by. Uh-oh. And it just wouldn't work out. So it also fails if you even try to multiply it, unless you just start multiplying wrong by doing, I don't know, column by column or whatever you think would be the right thing to do. I don't know. So yeah, there's a couple examples for you to look at. Hopefully you get some multiplying matrices practice there. Good job. Bye-bye.